page 1, we're given a very important theorem, the factor theorem. A number x equals c is a zero of a polynomial function f if and only if x minus c is a factor of f of x. Okay. So we have a function f of x, and you know f of c, let's back it up. We have, well, let's start over. We have a function f of x, and if c, x equals c is a zero of this function, polynomial function, then f evaluated x equals c is equal to 0, right? That's what we mean by x equals c is a 0, right? And for that value of x equals c, right, we also have an x-intercept in the graph of f of x at x equals c. Okay? If c is a real number. Now we're going to have cases in this section where the 0 x equals c can be a complex number. But if x equals c is a real number, okay, then the graph of the polynomial function has an x-intercept at x equals c. Okay? So in the factor theorem, okay, x equals c is the 0 of the polynomial function, then x minus c is a factor of f of x. That means f of x can be written as x minus c times some quotient q of x. There's no remainder, right? The remainder is 0. Okay. So when you put in c in for x, we have f of c is equal to c minus c times q of x. C minus c is 0. So this is 0 times q of x, which is equal to 0. Okay. So if x equals c is a 0 of the polynomial function f of x, then x minus c is a factor. And you can see when you evaluate the function at x equals c, right, you get f of c is equal to 0. So x equals c being a 0 and x minus c being a factor go together. Okay. In example 1, it says determine whether the linear polynomial is a factor of the given polynomial f of x. So in the first case, in A, the polynomial function f of x is a 4th degree polynomial, 3x to the 4th plus 5x cubed minus 5x squared minus 5x plus 2. Okay. And the linear polynomial is x plus 2. So is x plus 2, okay, a factor of this 4th degree polynomial? Okay. Well, x minus c is equal to x plus 2 in this case. So when we solve for c, right, c is equal to minus 2. So if we evaluate the polynomial function at x equals minus 2 and the right-hand side equals 0, then x plus 2 is a factor of this polynomial. If it doesn't equal 0, then x plus 2 is not a factor of this polynomial. Okay, that's what the factor theorem is telling us. So we evaluate the polynomial at x equals minus 2. If you do that right, you put in minus 2 in for x on the right-hand side. So we have 3 times minus 2 to the 4th plus 5 times minus 2 cubed minus 5 times minus 2 squared minus 5 times minus 2 plus 2 And now you got to do PEMDAS, right? Order of operations. And so the first term I got is equal to 48. Second term is equal to minus 40. The third term is equal to minus 20. The next term is equal to plus 10. And we got the constant term plus 2. And then when you do that addition and subtraction, I got 0. So f of minus 2 is equal to 0. So that means x equals minus 2 is a 0 of this polynomial function, and x plus 2 is a factor of this polynomial function. Okay. So x equals minus 2 is a 0. F of x and x plus 2 is a factor of f of x. Okay? That's what we can conclude based on the factors there. Okay? Any questions on that? In B, our polynomial function is the third degree polynomial x cubed minus 4x squared plus 8. And we want to know, is x minus 1 a factor of that third degree polynomial? Okay. Well, x minus c is equal to x minus 1 in this case, right? So c is equal to plus 1. So we evaluate the third degree polynomial at x equals 1. When we do that, we have f of 1 is equal to 1 cubed plus 4 times 1 squared plus 8. And when you do that arithmetic, I got f of 1 is equal to 5. So that's not 0, right? So x equals 1 is not a 0. It's not a 0 of f of x. So x equals 1 is not a 0 of f of x, and x minus 1 is not a factor of f of x. That's what we can conclude from the factors there. Okay. Any questions on that, ladies and gentlemen? Okay. All right. Fundamental theorem of algebra. The second version is most important. Every polynomial function at degree n has exactly n zeros. Okay. It has exactly n zeros. It has exactly n factors. Okay. So in example 2, we're instructed to find a third degree polynomial. Right, so that's n equals 3. That has zeros at x equals minus 2, x equals 1, and x equals 3, and whose x term has coefficient 4. All right, so p of x, p is the name of our polynomial function, okay, has a degree 3. So let me rewrite the zeros up here for a second. Okay, so the zeros are x equals minus 2, x equals 1, x equals 3, right, are the zeros. And so the factors of our polynomial are x plus 2, x minus 1, and x minus 3 are the factors. So our polynomial function p of x in factored form is equal to the leading coefficient a, right? I'm calling the leading coefficient a, and then times the three factors. Now riddle me this, ladies and gentlemen. The exponent on our three factors is the invisible 1, right? So this multiplicity 1 for each of the three zeros. Why is that? How do I know this multiplicity 1 for each of the three zeros? Because we're given to find a third degree polynomial. So n is equal to 3. And so the only way p of x can be a third degree polynomial with these three zeros is if the multiplicity for each zero is 1. Okay. All right. So now we have to find the value of the leading coefficient a. Okay. So we got to expand the right hand side to do that. Okay. So we got some algebra to do. So first, the way I approached it was I distributed the a inside the parentheses here. And so I have ax plus 2 times a. And then I FOILed x minus 1 times x minus 3. So when I FOILed x minus 1 times x minus 3, right, x times x is x squared. The outer is equal to minus 3x. The inner is minus x, so that comes to minus 4x. And then the last minus 1 times minus 3 is plus 3. Okay. So I FOILed x minus 1 times x minus 3 and got x squared minus 4x plus 3. Okay. Now, to continue to expand this, I treated this inside parentheses as one term, and I distributed it inside the parentheses here on the left. So I have 2a, where I have ax times x squared minus 4x plus 3 plus 2a times x squared minus 4x plus 3. All right, so I just used the distributive properties, right? I distributed the trinomial in parentheses inside the binomial parentheses on the left. And now I got to distribute the ax inside the parentheses here and the 2a inside parentheses here. So I have p of x is equal to ax times x squared is ax cubed minus 4x times ax is minus 4 ax squared. Ax times 3 is 3 times ax. So that's distributing ax inside parentheses here. And now I got to distribute 2a inside parentheses here. I have 2ax squared. And then 2a times minus 4x is minus 8ax. And then 2a times 3 is 6a. Now you gotta combine like terms. There's only one term involving x cubed. There are two terms involving ax squared. We have minus 4ax squared plus ax squared, which is minus 2ax squared. And then we got two terms involving ax. We got 3ax minus 8ax, which is minus 5ax. And then we have the term 6a all by itself. Well, we're told the x term has coefficient 4. So this is the x term, right? This is the x cubed term, this is the x squared term, this is the x term, that's the constant term. What's the coefficient for the x term? Minus 5a. And that has to equal 4. So when you divide both sides by negative 5, you get a has to equal minus 4/5 for this problem. Okay. So plug in minus 4/5 in for x, okay, or in for a, excuse me, minus 4/5 in for a, right, then gives us our third degree polynomial with the x term equal to plus 4. So we have p of x is equal to minus 4/5 times x cubed. And then minus 2 times a is minus 2 times minus 4/5, which is plus 8/5. We have plus 8/5 x squared. And then we know minus 5 times a is equal to 4, so we have plus 4x. And then 6 times a, 6 times a is 6 times minus 4/5, which is minus 24/5. So this is our third degree polynomial with these three zeros, and the x term is equal to plus 4. Okay. And this is called standard form. Right, this is the polynomial in standard form. And so you can see the leading coefficient is minus 4/5. So in factored form, right, this is our third degree polynomial in factored form. So we replace a with minus 4/5. And we have our third degree polynomial in factored form. We have minus 4/5 times x plus 2 times x minus 1 times x minus 3. Same polynomial, but in factored form. Every polynomial can be factored, right? So this is the third degree polynomial standard form, and this is what it factors to. Okay. Any questions on that, ladies and gentlemen? Are you ready to take the quiz? Let's do it.